distinguished jury members, respective guests, and fellow TEKNOFEST participants. We are Team AGROBOT, and we're very happy to be here to present our project on Hybrid Mobility AGROBOT for Smart Agriculture under the Agriculture category. Now, we have a number of things to talk about for today, but before we do that, allow us to introduce ourselves, please. So we are Team AGROBOT. Our team advisor is Professor Dr. Kasim Zishan. Our team captain is Osna Tiuma. Our beloved team member Abdul Malik Mili couldn't be with us today, unfortunately, as he's working on really cool. The rest of our team members are Muhammad Umar, Murtada, Mohammed, and Osama El Salibir. And myself, Aisha Gagazioğlu. Alright, so North Cyprus is famously known for its olives and citrus trees. But not only these, many agricultural products grow in North Cyprus, such as figs, strawberries, watermelons, apricots, and agriculture, growing crops, is not just a source of energy for North Cyprus. It's a way of living, it's a culture. However, there's a number of problems that are being faced by the farmers in North Cyprus, unfortunately. So these include the challenges, which are lack of mechanization, labor shortages, soil dryness, pests, and crop diseases. And we wanted to understand what the problems are that the North Cypriot farmers are facing. And for this reason, we went through the documents in thorough detail, and we wanted to know what was the problem. And we saw an overwhelming amount of challenges that were faced when it comes to combating crop diseases and soil dryness. And for this reason, we wanted to bring a solution. Drones and AI-driven activities have helped farming massively, and it's growing, it's continuing to grow massively. However, there are still some problems that come with them, and these are shorter flight periods due to high energy consumption, limited flying ranges, and limited sensor penetration. And for this reason, we have made it our objective to come up with a hybrid mobility robot that can roll and that can fly. And it can also perform 360-degree crop health monitoring. So, here we are presenting our solution. Our proposed solution is giving both aerial and ground surveillance. It has the rolling motion due to the exospherical structure that we can see here. And also, this is providing protection against the crops from the drone blades and also against birds. And we can do close range capturing, and we can do crop health monitoring. And in terms of applicability, our AGROBOT can actively move in muddy terrains, farmlands, level grounds, and near obstacles. And also, it can perform crop health analysis and soil. Innovation. We are aiming to revolutionize farming in TRNC. We want to bring solutions to the farmers. And for this reason, we are providing real-time AI diagnostics and smart fields, so instant geotagged reports, and also an integrated system with a live camera, and also precision at every level. Now, there is a number of local manufacturers in North Cyprus that are growing crops to produce products such as juice, jam. We have something that's called majul. You can try it at our stand. Olive oil, potato snacks. So these manufacturers are growing products at a large scale, and we want to help them. For the method part, my team member, Murtada, will carry on.
Thank you so much. And now, we will explore how we turn this beautiful idea to reality. We started off with our design, where we designed using SolidWorks to design an exospherical outer shell that can have extra flexibility and have great strength. This is connected to our gyroscopic frame, which is able to provide us with stability during rolling motion. Now, Another integral part of our structure is our drone base, where we run series of tests and analysis and simulations to ensure that it will withstand high dynamic impacts. Moving on to our mechanical system, which after our meticulous design was printed out using 3D PLA filament. And as you see here, we have pentagonal constructs that support the outer structure. This is connected to our gimbal system, providing easy manufacturing assembly and accessibility to farmers. As for our electronic system, we were able to bring this whole system together using a series of components such as the power module, the GPS system, our also ultrasonic sensor, and our camera, our Raspberry Pi camera, which will perform all the analysis. This system comes in Unity to provide us with real-time obstacle and crop disease detection. For the methodology we used, we were performing crop health analysis, where the images were taken on a Raspberry Pi camera, then geotagged to provide us with the location of these images, passed on through a neural network model named Oyolo 11N. This is able to classify all our images and give us insights about their health, multiple diseases that exist in them, and classify them, and then share it to our database, which is then displayed to the users and the user UI, and more on that later. Coming to our results, we were able to conduct speed tests where at a speed of 1.5 meters per second in average, we were able to achieve so by rolling motion. Moving on to the drop test, we started off with 20 centimeters, moving all the way to 85 centimeters, and this ensured that we were developing a structurally integrable project. Coming on to the AI model. Our AI model included parameters that were fine-tuned, such as weight decay, learning rate, and momentum. And this allowed us to achieve an accuracy of 85%, which will be further improved in the future by creating larger and larger data sets to train our model. As for our process management, all the data we have just described needs to be displayed to the user. Using our highly intuitive web app, the user is able to select which kind of analysis they would like to perform, such as vegetation analysis and soil analysis. After selecting this, the system automatically is able to perform and process all these images, and using vegetation indices, which are a series of formulae that are capable to give us various insights and properties about our crops. As you can see here, report summaries are created and smart recommendations are given to the farmers. We have also went with a mobile app. The mobile app is able to pull data from a Firebase database, display it on an intuitive UI, and then give us various insights and accessibility, such as capturing images from a live feed of the Raspberry Pi camera, displaying the AI results that we explained in the previous slide, and also giving us soil analysis and vegetation analysis reports. After that, conclusions are drawn, reports are given, and the farmers are given a very simple and effective experience. This is a representation of our physical prototype. As you can see, it is able to maneuver around multiple trees and farmland areas. It is able to fly and do its analysis, also mapping out and navigating different farmlands with different varied terrains such as sand and mud and soil. Now, we also obviously have to bring our product to the world. Now, we discussed commercialization and scalability strategies such as using real-time detection to provide valuable insights to the farmers on a simple intuitive UI and interface. We're able to dynamically map our products on high geographies and scales to the world. We would also discuss using going with agricultural cooperatives and NGOs to give us more and more exposure. We have also designed our project with UNDP sustainability goals in mind. And as we can see here, it provides a global annual growth rate of 22.1% for the agricultural drones sector.
We would like to thank our team for their presentations. I want to come to middle of the stage, please. And now we can our questions. I think, yeah. Yes, lady.
Can you? Yeah. Thank you for your detailed presentation, and I have some questions to understand deeply. What is the most critical spectrum that you have specified in your design? What is the critical feature for your design?
Most critical feature,
Yeah.
as a distinguishing feature.
Yeah.
The distinguishing features are actually two, not one. The first is the truncated icosahedron shape, which is similar to a football shape. This gives us traction and gives us easy accessibility in soil and terrain and mud areas. So making it simple for the farmers to navigate different terrains. We're also able to use PLA 3D printing so that we're able to have structural integrity and flexibility while moving on the farmland.
And you choose the material via PLA, okay? And can you choose another material for this design?
Absolutely.
For the stripe or the other one?
Absolutely. We are currently working on research and development to implement carbon fiber structures so that this will be able to give us even higher and higher strength and impact resistance. As this is prototype, a proof of concept, in our proof of product we will be able to improve it in many aspects.
Thank you for your presentation. Did you have a cost analysis? And also, how can you reach to compete with the other parts, like the other commercial products?
So would you like to repeat that?
Did you have a cost analysis? And how can you manage to compete with the commercial products?
I would like to pass it on to my teammate to so refer to him.
For post analysis, we are giving a web app. It's a very simple UI because most farmers usually need the very basic UI. So we tried our best not to go very fancy with it. You can go to the web app, select an analysis which you want to do, soil or vegetation analysis. And what we're doing is we're choosing indices on the basis of type. We've got MDVI, EXT, excess green index.
No, cost analysis. And how can you what is your price of
Post analysis or post? Sorry.
Actually, one of the things that we were keeping in mind is that when we were looking through the reports, we actually found out that there's a lot of waste when it comes to, for example, when they're producing citrus. Yes, there's a certain amount, but not all of them can be produced, so there's a lot of waste. So for the cost analysis, what we actually aim to do is that if we can provide early detection, then that's gonna help the farmers to detect if there's any problem first step before they go through food waste. And when it comes to competing with other drones, well, what we want to actually do is that we want to keep in mind that we want people from all age groups, from all regions, and for all backgrounds to be able to use our robot. Also at a time, for example, right now we are kind of frustrated that
You can use the microphone, please.
Okay, thank you.
You're welcome.
So we actually want to make a simple solution. We don't want to overcomplicate things. So what we're providing is that this is a very simple robot. It's very simple to operate. The web app portion of it is also pretty simple. And also they can save energy by the rolling motion as well as flying. So we actually want to make it cost effective in that kind of way. To go further on with the actual numbers, we would ideally like to provide numbers, but we want to do that in the next stage. Because first of all, we wanted to see that, okay, this is proof of concept. If we integrate these parts together, whether it would work or not. And we are happy with our vision, and we want to carry it on to make it a more cost-effective product. And we thank you so much for your question.
If I may add to the response, we were able to, as an estimate number, our research development process, it costed estimating a production rate of $700 only in the future, with the set fixes done to our project in the future. Thank you so much.
We would like to thank our team for their presentations. We wish them